say van der Waals. Okay. So we got three different types of forces here, three different types of intermolecular forces. I'm combining two lessons into one for this video right here. Intermolecular forces. There are three different flavors, and the flavors are right here. Van der Waals, dipole-dipole attraction, and hydrogen bonds. Hydrogen bonds aren't actually bonds, although the biologists think they are. These are the three different types of intermolecular forces. So if you've got a molecule, let's say like HF over here, and you've got another HF molecule right here, and another HF molecule right here, I can draw all the loose dot lone pairs if you would like. If that makes you happy, makes you sleep better at night. Ah, there we are. Now, intermolecular forces are the forces that occur between molecules. So this is a molecule, that's a molecule, this is a molecule. And we just saw that these are shaped like little light bulbs, where there's a lot more electrons around the F, a lot more electrons around the F. So it's more negative on this side, it's more negative on this side, it's more positive on the other side. Negative, and this is relatively positive, relatively positive, relatively positive. So the attraction that occurs between molecules, so there is an attraction between these and between this. So that force that you feel between the molecules, that is an intermolecular force. Inter meaning between molecules force. So here's a molecule, there's a molecule, there's a molecule. The force that occurs in between those molecules, that's an intermolecular force. Now there is also repulsion that happens right here. These guys are not going to like each other. They're both negative. They're going to be forced away from each other. But there's an attraction here. So depending on how strong this attraction is, they might get close enough like this. So they're kind of like, I don't like you, but I do like you. So they're going to get attracted to that hydrogen here since it's relatively positively charged. And they're negative, these fluorines. So the forces are hydrogen bonds, dipole-dipole, and van der Waals. Great. Let's start off with dipole-dipole, because that's probably the easiest to understand. That one is where you have these polar molecules, so they're polar, right? So is a molecule polar? Yes, it's polar, but it doesn't have these bonds right here. It's like a weaker version. These are very strong differences in charge, meaning that the hydrogen here is very, very positive, and this fluorine, oxygen, and nitrogen, if a molecule has these right here, they're going to have a very, very, very positive hydrogen, a very, very negative atom right here. So they're going to have a very, very strong difference in charge. So they're so strong that we give them a different classification called a hydrogen bond in between molecules with these bonds in them. But if it doesn't have those, it's a dipole-dipole attraction. So up here, it does have HF. So this thing right here makes it go into a hydrogen bond category. So the flavor, or the force in between here and here, these atoms and these molecules, it's a hydrogen bond. We can abbreviate that H bond if we want to. H bond. Okay, but what if it's not as strong? What if it's just like, I don't know, if we have an atom that looks like this. I'll just do something like this. Where it's clearly polar, right? And if it lines up with another atom, just say like this, clearly this is going to be the positive end, and it's going to have some kind of attraction to this negative end over here. This oxygen is going to be the negative end because there's more electrons crowded around oxygen. You wouldn't know that just by looking at this molecule, but I know that since I've been teaching this for a little while. This is going to be relatively positive. That's going to be relatively negative. So there's going to be some attraction here. What's that attraction called? Well, it's polar. These molecules, they are polar, but they don't have an HF, an HO, or an HN bond in them. They just have an HC and a CO bond. So we can't call them hydrogen bonds, but we can call this attraction between them, this intermolecular force, we can call that a dipole-dipole attraction. That's its force. Its intermolecular force is dipole-dipole. Dipole-dipole. All right. And the very last one is the weird one. It's van der Waals. And I'm going to explain that very quickly here. But all you really need to know is that if a molecule is nonpolar, it's only got a very weak force called the van der Waals force. Okay, so if it's nonpolar, it's not going to have this separation of charge like you have up here. It's going to be something like this, where you have, let me use a different color, where you've got like a CH4 right here, methane. Methane next to a methane. There's no real positive side to this. I mean, there's a little tiny bump right here, but the difference in charge is pretty equal in this molecule. So what happens with the van der Waals force is that they're very, very weak attractions in between the molecules. They do stick a little, and the larger the molecule, the more it sticks, which is pretty cool. But it doesn't stick very much. So when you get really close to this hydrogen atom, you look in close to this hydrogen atom right here. You look at the nucleus, and it's got its electrons that are whizzing around it. Sometimes it gets so close to another atom, like this hydrogen atom that's just floating by it, that this electron in this hydrogen atom actually starts to attract a little bit to the nucleus of the passing by hydrogen atom. So there's a very, very weak force right there. And when this electron gets attracted to that nucleus of that hydrogen that's passing by, it's not its own nucleus, it's a passing by nucleus. That also forces this other electron away. So it kind of like moves, it shifts this little electron cloud just a little bit. So it gets this little tiny tug between these two molecules right here. And like I just kind of said, if you have a larger molecule that has lots of C's like this and lots of H's that kind of branch out all the way back over here, you can start to have little tiny attractions between these neighboring molecules. And if they have enough of them summed up together, the overall force can be good. It can be pretty, really sticky. In fact, that's how like geckos climb walls. They get their skin so close to the surface that they're climbing on that they can climb on like the slipperiest surfaces just because their atoms get so close and they get so much of them in close contact. There's these van der Waals forces. They start adding up and they can hold their whole body weight up. It's really cool. But these are really, really weak. So compared to the hydrogen bonds and the dipole-dipole attractions, this intermolecular force is insanely weak. All right. I think I've gone through all of them. I hope this makes sense. I'll talk to you soon. Bye.